What if you could shrink down to microscopic size and travel inside your own body to witness what really happens after a single bite of food? Right now, beneath your skin, an invisible universe is constantly at work. Muscles contracting, organs communicating, enzymes transforming matter into energy. Today, we follow an unexpected guide on this journey: tater tots. From the first crunch to the final metabolic process, we'll uncover how the human body digests, distributes, and responds to every bite. Our story begins even before the food touches the lips. The brain detects the sight and smell of tater tots, activating anticipation pathways. Salivary glands awaken. The stomach begins preparing digestive acids. Hormones signal the digestive tract to get ready. The body doesn't wait, it predicts. As the first bite happens, the teeth become powerful tools of mechanical digestion. They crush and grind the crispy surface and soft interior into smaller fragments. This is more than chewing. It's preparation for a biochemical transformation. With every movement of the jaw, the surface area of the food increases. At the same time, saliva flows into the mouth, coating each particle. Saliva contains enzymes that begin breaking down carbohydrates almost instantly. Inside this warm, fluid environment, chemical digestion begins before the food has even been swallowed. With a coordinated reflex, the bolus moves toward the throat. The esophagus, a muscular passage, contracts rhythmically in waves known as peristalsis. These contractions gently push the food downward toward the stomach. There is no gravity involved, just precise muscular coordination guiding every movement. As the food enters the stomach, the environment changes dramatically. Gastric acids flood in, lowering the pH and breaking apart complex molecules. Muscles churn the food continuously, transforming it into a semi-liquid mixture called chyme. Enzymes work relentlessly, dismantling proteins and fats into smaller components. Nearby, the pancreas releases digestive enzymes that flow into the digestive tract. These enzymes accelerate the breakdown of nutrients, ensuring they can be absorbed efficiently. The liver prepares for its role, metabolizing nutrients, regulating blood sugar, and filtering substances that may need processing or detoxification. Slowly, the chyme moves into the small intestine, a marvel of biological engineering. Its walls are lined with millions of tiny finger-like projections called villi, each covered in microscopic structures that dramatically increase surface area. Here, nutrients derived from the tater tots begin entering the bloodstream. Carbohydrates are converted into glucose, a primary fuel source for cells. This glucose travels through the circulatory system, delivering energy where it's needed most. Muscles receive fuel to contract and repair. The nervous system uses glucose to transmit electrical signals. The brain, one of the body's most energy-demanding organs, relies heavily on this constant energy supply. Meanwhile, the lungs continue their silent contribution. With every breath, oxygen enters microscopic air sacs called alveoli. Oxygen binds with nutrients in metabolic pathways, allowing cells to produce usable energy. Without oxygen, the transformation of food into fuel would be incomplete. As nutrients circulate, the kidneys filter the blood, removing waste products and maintaining balance in fluids and electrolytes. Every organ plays a role, a coordinated system ensuring stability and efficiency. In the short term, carbohydrates from tater tots may create a rapid rise in blood glucose. Cells absorb this energy, potentially leading to a temporary boost in alertness and physical readiness. Circulation increases, nerve signals fire quickly, and muscles become energized. But the body also faces challenges when intake exceeds balance. Excessive amounts of highly processed or fried foods may irritate the stomach lining, causing inflammation or discomfort. Blood sugar spikes can be followed by rapid drops, leading to fatigue or reduced energy levels. The pancreas may release higher levels of insulin to regulate glucose, while the liver works overtime to manage incoming nutrients. Some individuals may experience sensitivities or allergic reactions, triggering immune responses that manifest as skin inflammation or digestive distress. Heavy digestion can slow intestinal movement, creating feelings of sluggishness or heaviness. yet the body remains remarkably resilient. Given time, hydration, and balanced nutrition, most systems recalibrate. Cells repair themselves, hormones stabilize, energy levels return to equilibrium. This ability to adapt and recover is one of the defining strengths of human physiology. Throughout this journey, every organ participates in a symphony of motion and chemistry. The mouth begins the process, the esophagus transports, the stomach transforms, the pancreas and liver regulate, the intestines absorb, the lungs oxygenate, the kidneys filter, the heart circulates, the brain coordinates it all. What appears to be a simple snack becomes a complex cascade of biochemical reactions, millions of processes unfolding simultaneously. Every nutrient has a destination, every molecule plays a role. Understanding this invisible world changes the way we think about food. Eating is not just consumption, it is transformation. Matter becomes energy. Energy becomes movement, thought, and life itself. And as our microscopic journey ends, we return to normal size, carrying a new appreciation for the hidden systems working tirelessly within us. The next time you take a bite, remember, inside your body, a vast and intricate process is already underway, turning every bite into the fuel that powers your existence. If this video is informative for you, please like, subscribe, and press the bell icon.